In this session, I am providing a glimpse of what is happening the first 24 hours and how we are ignoring a technology which is useful but saying that it doesn't change the pregnancy rate. Observations do not change pregnancy rate. It gives us more information and it helps us to deselect an embryo. In this journey, I will be providing some of the examples of the normalcy and the abnormalcy in the first 24 hours. In a conventional lab, after we do an egg pickup on a Monday, then we check for the fertilization check the next day. Sometimes, if it is 24 hours, we might miss if there is early pronuclear fading. And then we check the next step on, depending on the protocol of the lab, either on a Wednesday or Thursday. Then transfer the embryos depending on the protocol for day 3, day 4 or day 5. And in this, you're looking at snapshots. In these snapshots, what happens is there's a huge amount of information which we may miss it. So here you're seeing a pronuclear excursion, a 2 PNI, a cleavage, and all these things are not only visual impressions. It tells us more than what we know. We have failed to understand the implications of these things, and now we are trying to learn and reinvent the field of embryology. And the most important thing is there is a shift in the role of the embryologist from a technologist to a knowledge worker and a technologist. Unless the shift happens, they won't be able to sustain the future because the science of interpretation. So when we look at morphokinetic events in the first 24 hours, you have the polar body emission, the cytoplasmic wave, the appearance of the female pronucleus, the male pronucleus appearance, the juxtaposition, then the alignment, then the cytoplasmic halo, the cytoplasmic halo disappearance, the female pronuclear breakdown, the male pronuclear breakdown, and the cleavage. We are seldom exposed to any of these events when we are looking at embryology, and none of the published studies which publish or none of the speakers which speak about the time lapse are only speaking about the embryos and how much amount of pregnancy it improves. But one thing is, time lapse is all about deselecting an embryo. It's not for selecting an embryo. That's one crucial thing one should remember. Here I am showing you the polar body exclusion. For a long time it was thought polar body sizes, fragmentation will have a significant impact. But now more and more information is coming in that says that the second polar body exclusion, sizes of fragmentations really does not make so much of impact as we think. So the next area is, there is a frequency distribution of the polar body. The average distribution can vary, or the exclusion of the second polar body can vary between 2 hours to 8 hours. And if there is a significant delay beyond 12 hours, there is a significant drop in the pregnancy rate. The mean polar body exclusion after an ICSI is around 2.5 hours, and we should start looking at that information. And this polar body exclusion is followed by a cytoplasmic wave, and this always occurs 2 to 3 hours after the emission of the polar body and shortly before the appearance of the pronuclei. This cytoplasmic wave has been given a lot of studies at the basic science and at the animal studies because they feel the role of centromere has a role in cytoplasm, and more information is coming in that area. The cytoplasmic wave is different from halo. It's a peripheral space you see here. When you look at pronucleus, and anyhow I'll show the slide. Earlier we were only looking at pronucleus as fixed interval and grading them into different groups. But the fact is the pronuclear sizes and the movements which we seldom study. The movement of the female pronucleus towards the male pronucleus follows a set pattern. It alternates where the second polar body is excluded and moves to the position where the male pronucleus is there, and that's where the syngamy happens. So in this video you're seeing the movement of the pronucleus depending on where the male pronucleus is there, and then the appearance and disappearance of the female pronucleus and the male pronucleus also has an implication on the cell division. So these are events, physiological events, which we are not taught in the medical school, neither in our post-graduation, neither when we go into any CME courses. And these are the fundamental foundations of embryology, and this is what we are missing every day. When you look at nuclear precursor bodies, these we are given a lot of scoring saying that so many nuclear precursor bodies should be there, the alignment should be there, the movement should be there, the distribution should be there. But the problem with that was we are looking at a standard point of time of the nuclear precursor bodies, but not in a dynamic way. In that process, we lost a lot of information. I'll be showing an example. Here what happens is, you see the alignment between the two pronucleus and the disappearance and the fading of the pronuclei. All these things play a crucial role. We don't never give importance till now the time of disappearance of the pronucleus and the appearance of the two cell division. These are crucial basic physiological events which we must concentrate in the coming year, and I urge the embryological members of the society leaders to give emphasis on this area, so that what happens is we need not buy time-lapse imaging, but we should understand the events that happen in the first 24 hours and then in the first 5 days to look at this evolving knowledge. A PN fading, if it occurs before 20 hours, the implantation date and the blastocyst formation date is low. So there is a lot of information coming in that if the PN fading occurs too early also, it's not good. Then when you look at the first cleavage, all these synchronous events, if it happens in a synchronous time frame, then you have a good embryo. If the polarity of the cell division is not right, and if it is not in the longitudinal plane but happens in the transverse plane, then also your embryo and the blastocyst might be of the vacuole. These are key informations which we miss. So here there is the longitudinal polarity, and the next cell division occurs in the equatorial region, and that's how the 4-cell embryo in a flat type or the flower type appearances are described for a 4-cell embryo. These are the critical information which we never look at when we present our scientific data of how many of those embryos are bad. Only we look at blastocysts, and not every blastocyst is a good embryo. All along we have been taught that if a blastocyst does not implant, it may not be, blame the immunology or blame the embryo. When we look at the events that happen which are predictive of the pregnancy rates, the red lines are the non-predictive, the blue lines are the predictive. That means polar body emission may not be a predictor of live birth, but the appearance and disappearance of the pronuclei, the halo disappearance in relation to the first cleavage, and the pronuclear body disappearance to the cell division has all implications in the role of morphokinetics and our assessment. Here I will be showing you a couple of examples within those 8 minutes of time I have. Here I am showing you a 3pn and how we mistake a 3pn if we don't look at the right time. This is a schematic diagram. So here you see the one polar body being extruded and the second polar body is being there, that goes into the cavity, into the cell, and then you see later at this point you're seeing a 3pn. If we don't look at it at the right time, we feel it's a normal fertilization, and then if you look at the third day, we look at a normal cleavage embryo and then say that's a good blastocyst that did not implant. These are the fallacies. That's the reason I'm saying time lapse is not to select an embryo. You select an embryo so that you're having good quality embryos for transfer, and then not blame the uterus for the immunology, because that's the reason some of the good drugs that came into the field of immunology did not work, because our selection criteria of good embryo may not be the perfect thing. So here, if somebody looks at it, they say it's a perfect embryo, I transferred it, I didn't get a pregnancy. Maybe the problem is with the uterus or with the endometrium. Even when you look at the compaction, but here the compaction is getting disoriented again. Then again, you find a minute later a perfect blastocyst which we transfer, and we say this is having at least reasonable inner cell mass, not the perfect one. At least you should do a fair chance. But in reality, it's a bad embryo which we are considering because we are not looking in the right way and the information is not in the right way. Similarly, in abnormal pronuclei, in the abnormalities of the pronuclear, if a single pronucleus is there and you fail to look at it at the right point, then if it disappears, then you are missing a critical event, that you have a single pronucleus, and then you say that embryo did not progress or progress because you have a 2pn and a single pronucleus. And then when you look at the cell division, the fusion of the cell here, and then here you are seeing the embryo getting bad. So we say that we start thinking, did our embryology lab went bad because the fragmentation has come with a good fertilization rate. So are we looking at the right quality of information when we are interpreting the embryos in relation to environment? Sometimes we overlook all those things. So here I am also trying an example of a 3pn with a two polar body. You can have two types, 3pn with a single polar body. A female is the cause. The second is a 3pn with a second polar body where the sperm can be a cause. And these, unless you look at time lapse, you might miss them. So these are the lessons we are learning in time lapse, and the mechanisms of why these they don't get arrested and produce decent embryos or cleavage is an expanding field of embryology, and in the next couple of years to 5 years, the whole field of embryology, morphokinetics and PGD will change, because maybe at this time lapse is expensive. With time, technology becomes cheaper, and with integration of cell-free DNA from the spent culture media, a combination of time lapse and a cell-free DNA will really change our field to maybe one embryo, and it will really change that. And only then the possibility of looking at implantation failure comes in. Here, if you look at this point, you'll say it's a good embryo and we transfer. So these are some of the critical events. Now I move to a 3pn without a second polar body. So here you're seeing the 3 pronucleus, but when it fades, after 24 hours we miss it and then think it's a perfectly dividing embryo, and then we transfer it, and we freeze the other embryos, and then when the patient comes for a review, we say that we don't know why it failed. Here you are seeing pathogenesis sometimes. With the embryologist, there is no polar body, and the embryologist, if they forget to see the fertilization check and then check it later because of the workload, if they are done in the batches, then we look at a situation where you find an embryo that's not fertilized but going through a cell division, and then we say it's a fragmented embryo but a poor quality, but we'll transfer. These are some of the information that make a difference. So if somebody sees at this time, they say the embryo is alright, unequal blastomere, then they say reverse cleavage, but in the first place it did not undergo any fertilization. So and then we say this is a suboptimal embryo, and then transfer it. The field of embryology is going to change. Only thing is we are not realizing it. We are only counting a technology in terms of pregnancy rate, but not a technology in terms of amount of information it is giving us to understand the hidden world of the first 5 days in the incubator. Our learning in the last 3 years with time-lapse was, first of all, when we brought time-lapse, we thought it was for selecting an embryo. Then we realized it was for deselecting an embryo. That was one thing. The second thing is there was a huge learning because none of the data shows abnormalities of the PN appearance, and most of the articles are between 2000 to 2010. None of the current articles speak about them. So you have to go back into the literature, read that, then understand, and it's a huge evolving field. And time-lapse should not be looked into a cost. Time-lapse should be looked into a technology. There is no need to own a technology, but there is nothing wrong in learning the technology. I thank one and all.